This is a learning overview video. When we talk about learning, we're talking about memory, having information readily available when knowledge is needed to solve problems. Some aspects to learning is that it requires memory, it's a lifetime process, and learning is a skill. Every time you learn something new, changes occur in your brain, from forming new connections to strengthening old connections to consolidating and reconsolidating. The brain physically changes. The initial memory trace is consolidated through the neuron making new connections. When you retrieve a memory, it must be reconsolidated, adding further traces, such as where you were when you brought up the memory, how you used it, what the circumstances were around it, etc. This further strengthens the connection between the neurons and makes the memory more robust. The strengthening of neurons and networks, or traces, for long-term memory requires substantial time. For example, by the growth of new cell proteins, or cell biochemical rearrangements, both internally and externally. These changes typically require over 8 hours, which is one reason why cramming overnight does not contribute to long-term memory. Learning is more durable when it is effortful. This is easily seen in video gamers working hours to improve skills to reach the next level of play, or computer enthusiasts working in a garage, failing hundreds of times while working on the next billion-dollar idea. Students have attempted to learn SOLIDWORKS, several times, and some have even completed the course a couple times, but are still not experts at it. This is because the training did not tell the student how to correct mistakes and undo errors. Failure must be part of the process for strong retention. This is the opposite of current teaching methods that make learning fun and easy. Generative learning is the process of trial and error to solve problems before you are shown the answer. It promotes thinking about what information you need, how the information connects with other information, and what is important to solve the problem. When learning is hard, you are doing important work. Making mistakes and correcting them leads to advanced learning. 4 not always recognized as best practices are 1. Learning is deeper and more durable when it's effortful. 2. Rereading, highlighting, and mass practice are one of the least productive methods of learning. 3. Retrieval, spaced practice is more effective. And 4. Interleaving provides longer-lasting learning. The last section to cover is interleaving. A study by Hall et al. Points this out well. He took 2 groups of seasoned baseball players. The first group did batting practice by hitting a group of 15 fastballs, then 15 sliders, then other pitches in groups of 15, the mass practice. The second group hit 15 pitches in a row also, but the type of pitches was changed, never with 2 types of pitches in a row, the mixed practice. The mass practice group progressed well through several days of training, and the mixed practice group did not progress as fast. They became frustrated. The interleaving and spacing made the practice more arduous. This practice continued for 6 weeks. At the end, batting was assessed for both groups during a game. The mixed practice group did much better than the mass practice group, bringing their performance to a higher level than expected. Learning that is hard, spaced out, and interleaved produces better and longer-lasting learning. This ends the video on the overview of learning.